Hi all, now I am going to discuss about my third equation of motion, that is v square equal to u square plus 2s using integration method. Before going to discuss about it, let me observe it from a physical situation. Let us consider 2 points A and B. In the starting of the motion, when position covered will be 0 or displacement will be 0, initial velocity at that time u, let's say u. Now similarly, when position covered will be s1, now final velocity will be v. Let's say initial velocity is u1, final velocity is v1. So what I am trying to say is, actually when you are changing your velocity from u1 to v1, you have to travel some distance, or you have to cover some distance, or you have to change your positions from one place to another place. Then only you can increase or decrease your velocity. It's all about non-uniform motion. You have to increase or decrease your velocity, or simply you have to change your velocity. So to change your velocity, you have to consume some time. In the previous video we have seen how we are consuming time and getting an equation, that is v equal to u plus at and s equal to ut plus half at square. Similarly here in this case, we are traveling some distance or changing our positions from initial to final to change our velocity. So this is a third equation of motion, and here we are considering acceleration also. So we can start. In instantaneous velocity is given as, or simply you can start, instantaneous acceleration is given as, instantaneous acceleration is given as derivative of velocity with respect to time. Let us multiply 1 ds and divide 1 ds, small displacement or small position, small change in position or small displacement above and below in the numerator and denominator. Now let us shift this ds here, dp by ds into ds by dt. I am just shifting ds to here and dt to here. So I will get a equal to dv by ds into ds by dt is nothing but v. V is rate of change of position. Small change in position with respect to small change in time is velocity. So now it will be a ds equal to v dv. So a ds equal to v dv. So I can also change this to the left hand side and to this to the right hand side. So v dv equal to a ds. Now I will do the integration. So since I want to do the integration, so I have to check what are the variables in the first. The variable is v. So basically velocity is changing from initial position to final position, from u1 to v1. So velocity is the variable. The lower limit of velocity is u1. The upper limit of velocity is v1. The upper limit of velocity is v1. Similarly, a is constant here, acceleration, and ds, change in position. To change the velocity from u1 to v1, we have to change our position from 0 to s1. 0 to s1 as shown in the figure. So now v dv integration will be v square by 2. Already I have done this. t dt will be t square by 2. x dx will be x square by 2. So v dv will be v square by 2. Now u1 to v1 equal to a is constant, ds 0 to s1. Now take 2 common outside. Now v1 square minus u1 square. I am doing it directly. First I put v1 here minus then u1 here. Now integration of ds is s, that will be 0 to s1. So this will be v1 square minus u1 square by 2 equal to a s1 minus 0. So now v1 square minus u1 square by 2 equal to a s1. So I got v1 square minus u1 square equal to 2a s1. Now v1 square equal to u1 square plus 2a s1. Let us consider, let u1 equal to u, v1 equal to v, and s1 equal to s. So the above formula will become v square equal to u square plus 2as. So this is my desired equation of motion, that is equation of motion 3. So now I will derive the fourth formula, that is snth equal to u plus a by 2 2n minus 1. Without going to the derivation directly, let us understand what is this. So this diagram is really important, what I am drawing now. Let's say this is A, this is B, this is C. Let's say body is taking n second to go from A to C. The body is taking n second to go from A to C. So Sn is nothing but AC is equal to distance covered by the body in n second. Distance covered by the body in n second. Now let the body is taking n minus 1 second to go from A to B. So Sn minus 1 is AB. That is distance covered by the body in n minus 1 second. So AC is the Sn, that is distance travelled by the body in n second, and AB is Sn minus 1, that is distance covered in n minus 1 second. So my BC will be Snth. So Snth will be BC. What is that BC? BC is nothing but AC minus AB. AC minus AB. So what is AC? AC is Sn minus Sn minus 1. That is distance covered in nth second or last second. Distance covered in nth second or last second. A little bit clear example. Let's say from A to B, a body is taking 4 seconds. Okay. Let's say from A to C, a body is taking 5 seconds. So AB, I can write S4. It means distance covered in 4 seconds, not 4th second. It will be 4 seconds. Distance covered in 4 seconds. Now SC equal to S5. Distance covered in 5 seconds. So BC will be SC minus AB. That is S5 minus S4. That will be S5th. Because Snth will be Sn minus Sn minus 1. Snth will be Sn minus Sn minus 1. So S5th will be S5 minus S4. So the distance travelled in 5th second or distance travelled in last second. This will be our S5th. So Snth is Sn minus Sn minus 1. I can say Sn is nothing but distance travelled in n second. That is Un plus half An square. And Sn minus 1 is nothing but distance travelled in n minus 1 second. That is U into n minus 1 plus half into a n minus 1 square. So what you need to do is, you need to subtract this second equation from first equation. It will become Sn minus Sn minus 1. And you will finally get U plus A by 2 2n minus 1. So this is a simple method. I will do it in a method 2 using integration. So I am leaving this up to you. So you just subtract second equation from first equation to get this. I will do in a different way, that is using integration. The way we have done S equal to ut plus half at square. So instantaneous velocity is given as v equal to ds by dt. So ds equal to v dt, and we know v equal to u plus at. Our first equation of motion, we know v equal to u plus at. So ds will be u dt plus at dt. Now I want to put integration. Now let me draw a graph here or diagram here. AC, okay, sorry, this is AB, this is C. Let's say here time taken is 0 second, here time taken is n minus 1 second, here time taken is n second. Now here position is 0, here position is, let's say, Sn minus 1, and here position is Sn. So just try to understand. When the body is at A, when the body is at A, time is 0 and position covered is 0, or position change is 0, initial position is 0. Displacement will be 0. When the body is reaching at B by consuming some time, that is n minus 1 second, the position change will be Sn minus 1 from 0. When the body is reaching at C, it is consuming n second starting from A, and the position changes Sn from 0. So I want to do integration between B and C. So here the variable is position. So between B and C, the position is changing from Sn minus 1 to Sn. So I am putting my lower limit as Sn minus 1 and upper limit as Sn. Now u dt, here dt is the variable, time is the variable. So when the body is changing its position from Sn minus 1 to Sn, the body is changing its time from n minus 1 to n. So n minus 1 is the lower limit of the time when the position is Sn minus 1, and n is the upper limit of the time when the position is Sn. So this is also time, so I am putting n minus 1 to n. Now ds, integration of ds is s, that will be Sn minus 1 to Sn, u taken common, integration of dt, n minus 1 to n, plus a taken common, integration of t dt, n minus 1 to n. So this will be Sn minus 1, upper limit minus lower limit u, integration of dt is t, n minus 1 to n, a, this is a, integration of t dt will be t square by 2, n minus 1 to n. So this will be Snth, because already I have told Sn minus Sn1, Sn minus 1, Sn minus Sn minus 1 is Snth. So this will be u. Now for t I can put n minus, for t I can put n minus 1 plus a by 2. For t square I can put n square minus, for t square I can put n minus 1 whole square. So this, I am shifting this to here. Now Snth equal to u within the bracket n minus 1. So n minus n minus plus 1 plus a by 2. Now within the bracket n square minus, within the bracket I am trying to do it a minus b whole square, that is n square minus 2n plus 1. So Snth equal to n cancel, that will be u plus a by 2. Now I will do n square minus plus 2n minus plus minus 1. Very simple, you can do it in home also. Snth equal to u plus a by 2 2n minus 1. This is my desired equation of motion. So now we are going to discuss the most important concept in kinematics, or the last concept, that is relative velocity. So till now we are taking earth is constant, we are moving a car or a body or a truck or a bus, they are going with respect to earth, keeping constant. But here now in the relative velocity, I will be discussing when two bodies or two cars are approaching towards each other, or one car is trying to overtaking another car. So in relative velocity, the simple thing, you just remember, I will solve one question, then only you can understand. So VAB, that is velocity of A with respect to B. Now VAE, that is velocity of A with respect to earth. Now VBE, that is velocity of B with respect to earth. So the simple formula VAB, velocity of A with respect to B, equal to velocity of A with respect to earth minus velocity of B with respect to earth. Velocity of A with respect to B equal to velocity of A with respect to earth minus velocity of B with respect to earth. I'll apply this formula with a very famous concept, that is ran and man. So basically, man is going, man or man, let's say man is going in a road when rain is falling. So man has to hold an umbrella to avoid that rain, or in order not to get wet from the rain. So this is a special case of relative velocity where we are always calculating velocity of rain with respect to man. We are not going to calculate velocity of man with respect to rain. So let us consider a man is going from west to east. Let's say this is velocity of man with respect to earth. I am writing the question. A man is going from west to east at a speed, let's say 4 kilometer per hour. Let's say man is going from west to east at a speed 4 kilometer per hour. Okay, one new concept. People are always getting confused. Often people are getting confused. This is east, this is west, this is north, this is south. Since the blackboard since the whiteboard is in the vertical direction, so east, west you are taking in the plane. North, south you are feeling that north is above. No, but this is basically plane. If I take it from the top view, this is my hand, this is my east, west, and this is my north, south. So east, west, north, south will always lie in one plane, and rain will be always falling from the top. Rain will never fall from east direction, neither from north, neither from west, neither from south. It will be south of vertical or east of vertical or west of vertical or north of vertical. Not exactly like that. It will be some angle with respect to vertical. So you remember south, east, west, north will be in one plane, and vertical is perpendicular to the plane containing south, east, west, north. Okay. So man is going from west to east at a rate of 4 km per hour. The rain is falling vertically downward at a speed 3 km per hour. So rain is falling vertically down. This is velocity of rain with respect to earth. So velocity of rain with respect to earth is given as 4 km per hour, and velocity of rain with respect to earth is given as 3 km per hour. So our job is to find at which angle the man should hold his umbrella to avoid the rain. At which angle, or how the man should hold his umbrella. How the man should hold his umbrella to avoid rain. Okay. So avoid rain means when the man is standing, rain is falling. When the man is walking, rain appears to fall little bit in a slanting way. For example, if you have gone with your father in his bike by holding an umbrella, you always used to show the umbrella towards front side, not towards back side, towards front side, because when you are at rest, rain is falling vertically. According to this question, rain is falling vertically. This is the actual speed of the rain. But when you are moving, then rain appears to fall in a slanting way. So rain, by making some angle with the vertical, rain is appearing to fall like this. That's why we are holding our umbrella like this while sitting behind our father or mother in a scooter. Okay. Now velocity of rain with respect to man will be, according to this formula, velocity of A with respect to B, velocity of A with respect to earth minus velocity of B with respect to earth. So velocity of rain with respect to man will be velocity of rain with respect to earth minus velocity of man with respect to earth. So velocity of rain with respect to earth minus velocity of man with respect to earth. So this will be my velocity of rain with respect to earth. So for minus velocity of man with respect to earth, I have to write like this. Velocity of man with respect to earth. This will be minus. So the resultant will be like this. Or if I use I cap and j cap, I'm just writing it. For velocity of rain with respect to earth, I can write 3 km per hour and rain is falling vertically downward. Let's say that vertical axis is taken as j cap, but along vertical axis downward means minus j cap. So minus 3 j cap. Now minus. So what is velocity of man with respect to earth? Velocity of man with respect to earth is 4 km per hour towards east. So let's say this is 4i cap. So minus 3j cap minus 4i cap. How can I represent minus 4j cap? 1, 2, 3, 4. Sorry, minus 4i cap. 1, 2, 3, 4. Negative x-axis minus 3j cap. 1, 2, 3. So this will be my velocity of rain with respect to man according to vector. But the simple technique, without doing these things, you can directly put the values here. Velocity of man with respect to earth is along this. Velocity of rain with respect to earth is this. So velocity of rain with respect to main is velocity of rain with respect to earth minus velocity of main with respect to earth. So this will be minus velocity of main with respect to earth, because minus velocity of main with respect to earth is the negative vector of velocity of main with respect to earth. In vector, we want to change by an angle 180 degree or multiply a minus sign, so it will be a negative vector. So this will be minus velocity of main with respect to earth. This will be velocity of rain with respect to earth. So velocity of rain with respect to man will be velocity of rain with respect to earth minus velocity of main with respect to earth. So this is the velocity of rain with respect to main. I can draw from there. So I hold my umbrella like this. Rain is falling like this. So I will hold my umbrella like this. It means the man is going in this direction. The man is going in this direction. So he should hold his umbrella by an angle theta. So it's very easy. This is theta, this is theta. Now let us try to find out theta. This will be 4, this will be 3. So tan theta, if this is perpendicular, tan theta will be P by B, 4 by 3. So theta equal to tan inverse 4 by 3 with respect to vertical. With respect to vertical. So this is all about relative velocity and rain and main. Hope you are clear. After this, I think this is the last part of motion in 1D. Okay, we cannot say this is a motion in 1D. Actually, I am introducing motion in 2D concept here. In my next video, I will discuss projectile motion and river boat, which is very, very complicated and important also. Thank you.